Okay, great, Jens. Let's answer some past paper questions for trig functions. This is what you're getting tested on now in this upcoming test, so you need to know all of this information. Now, before I go to the answering of past paper questions, I want to explain some stuff. Okay, things that you should know already, and some stuff that are implied that you know already, but I'm going to explain it to you. Okay, let's talk about our sine graph. We know that it starts at 0, goes up, goes down, that there has a period of 360 degrees, meaning it takes 360 degrees to complete a full cycle. Okay, this here is the original equation. Nothing is changed by it. We know that our amplitude is 1. How do we calculate amplitude? Maximum minus the minimum divided by 2. Okay, so that's 1 minus 1. That is 2. 2 divided by 2 is 1. Okay, then I already spoke about the period. The maximum you can see is 1. The minimum you can see is -1. The range of this, range talks about all the y values for which this graph exists. It starts at -1 all the way till till +1. Those are the y values that it can touch. So our range y is an element of -1 all the way till +1, basically minimum to maximum. Okay, did you see the shape? You need to know the shape of your sine graph. Okay, so that you can know if the thing got shifted down or if it got reflected or anything like that. Then we go to the cos graph. The cos graph starts at the top, goes all the way, cuts the x-axis, goes down, turns, cuts the x-axis, turns, comes back to the top. This one here again has an amplitude of 1, because 1 minus -1 giving me 2, divided by 2 giving me 1. Okay, all right. This here also has a period of 360 degrees. It means it takes 360 degrees for itself to complete a cycle. The maximum is at 1, the minimum at -1, and therefore the range is between the minimum to maximum, so -1 to 1. Then we go to the tan graph. The tan graph has asymptotes. Okay, I explained it in class to you guys. As you know, when your sibling comes really close to that line that you drew, they don't touch it, but they're really close to it. That's what I'm talking about, these asymptotes. It means the graph won't touch this line at all. Okay, the first one is at 90 degrees, and then the next one is 180 degrees more. The next one would be 180 degrees more, etc, etc, etc. Okay, this one here, it has a period of 180 degrees. What does that mean? It means from the beginning of it all the way to complete one cycle, it takes 180 degrees. So can you see here in this domain of 0 to 360, can you see it repeated itself twice? Okay, all right. This one here has a maximum of infinity and a minimum of -infinity. It's not stopping anywhere. And because of that, our range is y is an element of real numbers, because we don't know where it's starting and where it's stopping. Okay, it's important that you know that. Then you need to know that if I put a value in front of any of these graphs, so over here, a value, and an a value. What do I mean by a value? Any number. Okay, I can make it 2 or half or 3 or 6, any number. What it does to the graph is it stretches the thing out vertically. Okay, and because it's stretching it up vertically, so this point here would go to 2 if the number here in front of it was 2. It would go all the way to 2, and this one here would go all the way to -2. The shape of it otherwise stays the same, but it's just getting stretched up and down. Now, because it's getting stretched up and down, it changes the amplitude. Here's the formula, maximum minus minimum divided by 2. And also, it's getting the new maximum and minimum, so it's affecting the range. So that's important that you know, okay? Then you need to know that if that amplitude value is a negative, so if here I put in -3 sine x, or -half cos x, or -7 tan x, whatever, as long as it's negative, what it's doing is it's reflecting the entire graph the other way around. So this is our original. This here is the reflection going in the opposite direction. Same thing for the cos graph, same thing for the tan graph. Now you need to know this, okay? This is very important that you understand all of this information, and that this information is stuck into your brains, because we need this information to answer the questions. Okay, let's talk about the Q value. The Q value, what it does to the graph is it basically shifts the whole graph either up or down. So it doesn't change the amplitude, it changes the maximum and minimum, yes. And because it changes the maximum and minimum, it affects the range. So it's the whole graph as is, just shifted up or shifted down. That's what you need to know. All right, let's talk about some transformations. Okay, you might have questions that say determine the range of f of x if f of x is translated 2 units down, or determine the minimum turning point of g of x if g of x is a transformation of f of x translated 2 units down, or something like that. Okay, now I summarize them for you. If I say translated so many units, that I put in 2 as an example, 2 units down, it means you take your whole graph and it's shifting 2 units down. Now because it's shifting 2 units down, isn't our maximum changing by 2 units or less than 2 units, and even our minimum is going to be less than 2 units? And because that maximum and minimum are also both 2 units less, our range is going to change. That's what I wrote here for you. Okay, subtract 2 from both the minimum and maximum. If I say it's translated 2 units up, that means the whole graph plus 2. Okay, and the whole graph is shifted 2 units up. Again, it's affecting the range, so you're going to add 2 to the minimum and add 2 to the maximum. Then we could say reflected. They could say determine the maximum if f of x is reflected along the x-axis or about the x-axis. It means that every y value becomes negative y, and because of this here, it's going to be a reflection. I already showed it to you in the opposite direction. Okay, right? So that means its minimum would become its maximum, and its maximum would become its minimum. If I say a vertical stretch of 2 units, this changes the amplitude. I already discussed this with you. It's the A value. It's just stretching it up and down. Okay. Now you might see some questions like this. It's going to say for which values of x will, and then they'll tell you f of x greater than 0 or stuff like that. I summarized all of the possibilities for you, and this possibilities that I summarized for you over here is very helpful for grade 11 as well, and it's helpful for grade 12. Not just for trig graphs, it's also helpful for your normal algebraic functions, and in grade 12 it's helpful for your calculus as well. So please understand this properly, and always, if you need to come back to these type of things, come back to this video and come and watch this again. Now when I say f of x greater than 0, what do I mean? I mean, where's my graph above the x-axis? Because greater than 0 means positive, isn't it? Any number greater than 0 is a positive number. And where's the positive y numbers? It's on this part over here, the top part. So I'm saying anytime I see f of x greater than 0, I mean above the x-axis. So I went ahead and I just drew some graphs on the side here for you. This particular graph has a domain of 0 to 630. Okay, can you see this part over here is above the x-axis, this part over here is above the x-axis? And you would notice I use lots of color pens with this. It makes it so much easier if you use color pens. Now how do I write my solution? So that means my solution is somewhere in between 90 and 270. So you put the x in between 90 and 270. Or it could be between 450 and 540. So you write it down. X is between the 450 and 540. Okay, that's what you're doing. If I ask you f of x greater than or equal to 0, same what I just explained right now. Just instead of it just having, see how this one here just has the less than, this one here has the less than and equal to 0. So if you see the equal to part, make sure your answer also has the equal to part. The only time that it will have an equal to part, but you might have to change it up a bit, is if it comes to an asymptote. Remember, an asymptote doesn't have equal to, it can't equal to the asymptote, so just be aware of that. Okay, so see here, it's between 450 and 540. I did that. The inequality, when you're saying between two numbers, always faces towards the left. Okay, always, always, always. And I put the equal to parts. Moving on, if I say f of x less than 0, this here is asking where is it below the x-axis. I went ahead and I highlighted it for you. This part, this part, this part. Can you see here's my x-axis? So I'm asking where's my graph underneath that, underneath my pen. There, there, and there. Again, similar scenario, you need to just write down our solutions. So can you see this line here is 0? So between 0 and 90, between 270 and 540, and then between 540 and 630. Okay, and that's it. If it said f of x less than equal to 0, same as the above, only this time it's going to have the equal to signs. Equal to signs, equal to signs. Okay. Quick thing here, if it said f of x less than equal to 0, okay, so that means we know it's all included. But let's say this bracket over here was a circle one. You guys know that a circle bracket means not included, so all of these would be included, except this one here you would not include it, because if this was here a circle bracket. Okay, I'm just making you aware of it. Let's move on. Okay, we're getting a little more tricky. Oh no, this one not yet so tricky. It says, where's f of x equal to 0? That's basically just asking, where's my y equal to 0? And we know where y is equal to 0 is the x-intercept. So for this graph over here, between 0 and 360, it's equal to 0 at 90 degrees or at 270 degrees. Just pull this down. There we go. And you just write it down like that, okay? This one isn't an inequality, right? The next question, getting a little more tricky. Where is f of x greater than g of x? This here is asking, where's your graph of f of x above the g of x one, okay? So what I want you to do for this is use your highlighters. It makes your life so much easier. Highlight your f of x, highlight your g of x, and then ask yourself, where's purple on top of pink? That's all you're asking yourself. So you're going to do this. You take your ruler. Okay, I don't have a ruler with me. Let's pretend I'm using my pen as my ruler. Okay, and you put your finger, your ruler as you're going along over here. So can you see at this point over here, purple is on top of pink, and that's what I wanted. I wanted purple on top of pink. So that means everything from 0 all the way up until this point 90. Okay, purple is on top of pink, because the minute it touches that 90, do you see over here? Pink now becomes on top of purple, okay? Pink on top of purple, that's not what I want. So my first solution is from 0 up until 90. There it is written over there, okay? My second solution is, do you see from the minute it touches that point of intersection, the dotted line that I drew over there for you to understand that that value there is 225. Okay, it's not an asymptote. From that value all the way up until the 360, do you see my purple is again on top of my pink? So I'm going to write from 225 up until 360 again. If I give it to you as f of x greater than or equal to g of x, same thing like what I did, just this time it must be included. That's all, okay? If I say it the other way around, f of x less than g of x, it's where is my pink graph now on top of my purple graph, okay? And you'd go back to the diagram again and see where's my pink graph on top of purple. We already discussed this. Can you see from this point over here till this point over here, pink is on top of purple. You can see it. Okay, so that means from 90 degrees till 225 degrees. So there we go. From 90 degrees till 225 degrees. The x is in the middle. Always face your inequalities towards the left. Again, if they say f of x less than and equal to g of x, same thing like what I just explained over here, just it's going to have the equal to signs. Okay, getting a bit more tricky. Okay, this one here, and you will see questions like this in your paper, so please be prepared for them. It's asking, where's f of x times, because remember when we see a dot, it means multiplication. So where's f of x multiplied by g of x greater than 0? Let's understand what this means. It says, where is, if I take the y value of f of x times the y value of g of x, if I multiply the two of them, where am I going to get a positive number? Because remember, greater than 0 is a positive number. So what we do for this, and this one requires a little more work, okay? The places where you can get something positive if you multiply two of them is if it's positive times positive, isn't it? We learned this grade 8 and 9, integers, or a negative times a negative. Okay, so I put down two separate options, and what I like to do is just quickly resketch the graph for myself. If you can do this without resketching it, by all means do that. I just make it easier for myself to understand. Okay, now what I did, I sketched the graph in question twice, one for the positive times positive and one for the negative times negative. That's what I'm doing. Okay, I then went ahead and I took my pen, I had a gold pen over there, and I just marked off all the important points because we're going to be talking about between two important points. So I see near 90 degrees is an important point. They both touching each other there. This one here, 225 is an important point. They touching each other again. 270 is an important point. It's the x-intercept of this one. And 360 is an important point. It's the x-intercept of this one. And obviously this line is an important one. It's basically where they started, right? Now if I say positive times positive, okay, I mean f of x positive times g of x positive. So I wrote it here. F of x greater than 0, g of x greater than 0. Okay, positive meaning greater than. So for this f of x greater than 0, I went and color coded it here for you. F of x is in this icy blue color. Okay, there it is positive, and there it is positive. Reminder, what's positive? It means everything above the x-axis. So everything above my pen would be positive. Then it says, where's g of x positive? This particular graph of g of x, can you see it doesn't go anywhere past that x-axis? There's no part. Let's do that for you. Can you see over there on that top part over here? There's no g of x. So I can't highlight anything in this orange, and I even wrote it here for you, none, because the whole graph is below the x-axis. So there isn't going to be a solution for this one here, okay? But I just did it to show you exactly what is happening, right? On this idea where it's negative times negative, that means f of x negative, g of x negative. So I did that, f of x negative, g of x negative. Reminder, less than 0 means negative. Drew the graph, I filled in the important lines there for myself just so that I know as well, and it becomes easier. And I color coded for myself. F of x less than 0. So that means I'm asking, where is the f of x graph, right, below the x-axis? And there you can see I colored it in pink, right? And then I'm asking, where's the g of x graph, also less than 0? And I colored in the whole thing in blue because it's less than 0 over there. Now I'm asking myself, where do the two colors meet each other? All right, where are both the colors highlighted, basically? Can you see here between 0 and 90, only the blue part is highlighted. This part here isn't pink, so it doesn't work. From 90 to 225, the important points again there, can you see both of them are colored in this interval, 90 to 225? So that's where they both overlapping. So I wrote it down here, from 90 degrees to 270 degrees, both of them are colored in at the same time. They're both negative at the same time. Let's go see. After 225, okay, again, they colored in, both of them over here are colored in. And from 225 to 270, they're also colored in. The minute we go past 270, do you see that this part of the graph is not colored in? From 270 to 360, not colored in, right? So that means our solution is just between 90 degrees and 270 degrees. I'm going to repeat that. From 90 to 270, can you see my blue graph is colored in? And this graph here is also colored in. I have two colors both intersecting or overlapping with each other. So I just need to write my solution somewhere from 90 to 270, right? And that's over here, 90 degrees to 270 degrees. Don't forget, inequality always facing towards the left. If it says f of x times g of x greater than or equal to 0, same thing, just we are including it in this time. Okay. Same situation or same concept, just this time it's f of x times g of x less than 0. So now we know that something is less than 0 or negative. If we multiply two numbers and we get an answer that's negative, it's either we did a positive times a negative or a negative times a positive. So I'm doing the exact same thing like I did over there. Color-coded, where's f of x, because positive, greater than 0. Here is it greater than 0 above the x-axis. There's the x-axis, so above the x-axis there. Where else is it positive? This part over here, above the x-axis. Then I want g of x as a negative, so less than 0. That pretty much is the whole graph. Okay, for the other side, I want f of x as a negative. That's from here till here because negative is less than the x-axis. And g of x is a positive, isn't it? Now, can you see in this graph over here, our g of x can't go anywhere past the x-axis, so it doesn't become positive, it just stays negative. The whole of the g of x graph is below the x-axis. Now we're going to write down our solution. This side here doesn't have a solution because there's no overlapping. This side does have a solution. Where is it? Can you see between 0 and I marked off all the important points again. See between 0 and 90 degrees, both colors. From 90 to 180, only one color, so we're not working with that. From 180 to 225, again, only the one color, the pink one, not working with that. 225 to 270, only the pink, not this one here, so we're not working with it. 270 to 360, can you see blue and pink? Both graphs are highlighted. Okay, so we see both colors. So where are we going to write our solution? Between 0 and 90, both colors highlighted. Between 270 and 360, both colors. So how do we write our solution? Between 0 and 90 or 270 and 360. Don't forget to put the x in the middle. Always faces the left hand side. If it's a sandwich, it's sandwiched between the 0 and the 90 or sandwiched between the 270 and 360. Same thing if they say f of x times g of x less than or equal to 0. Same thing, just this time we're going to have it included, isn't it? And the last one like this, and this one is the more difficult one. I say it's difficult, but the concept still stays the same, okay? Same like how we did the previous one, okay? It's asking where is the question. X times f of x greater than 0, okay? This is basically asking where is the x value of my graph times the y value of the graph going to be a positive. So here's the graph in question. I just scribbled one out for you. The interval is negative 450 to 360. Negative 450, 630, not 360, 630. Where would something be a positive? It's if we have a positive times a positive. So that means this must be positive and this must be positive. X greater than 0, f of x greater than 0. Or else it can be negative times a negative, right? So that means x less than 0 and f of x less than 0. I did the same color coding thing. X greater than 0, that means all of the side of the graph is greater than 0. Remember on the side here, this side x is greater than 0, this side here x is less than 0. So this whole part over here, x is greater than 0, and I colored it in blue. I'm sure you can see it now if I focus. Can you see all here is also blue, right? And then I wanted to know where f of x is greater than 0 because both of them have to be positive. So it's greater than 0 over here and here. That means above the x-axis. Let's highlight on the side over here. I want x to be less than 0. That means all on the side here, x is less than 0. So I highlighted the graph in blue. Then where's f of x less than 0? It means less than the x-axis. It's this part over here and this part over here. And here on the camera, it's starting to look like a green color over here by the two intersections, I think. Yeah, it's looking like a green. But anyway, we're asking where the two colors overlapping. So you can draw those lines like how I did with the gold pen, but they are overlapping from 0 to 180 and then again from 360 to 540. So our answer is going to be 0 to 180 or 360 to 540. All right. For this option over here, where are they overlapping? Can you see over here it's overlapping and over here it's overlapping. basically created a new color. Okay, so that means between negative 450 and 360, and then again from negative 180 to 0. And there we go, negative 450 to 360, 180 to 0. We need to write it out as an inequality. Negative 450 to negative 360, and the other one negative 180 to 0. If it said same thing, x times f of x greater than equal to 0, do the same thing, just it's included. It could also have it as x times f of x less than 0. Same thing over here. You just know that less than 0 means negative. A positive times a negative gives you a negative. Or for option 2, a negative times a positive is going to give you a negative. And then you just do the same highlighting and color coding thing. Let's answer a past paper. All right. Okay, this is the question, and this is what we were doing in class for whoever I seen today, which is Monday the 16th. Whoever was in class today, this is the question we did, and it's going to make it easier for you to understand now that you're watching the video and reinforcing the idea. It says sketched below. Oh, this should have been sketched. Okay, I got it from November 2019, paper 2. It's question 5. Sketched below are the graphs of f of x, which is 2 cos x. Now, before I continue, let's analyze this. Can you see there's a 2 in front of here, which means it affects my amplitude. My amplitude is going to become 2. My maximum is 2. My minimum is negative 2. Just by looking at that, that's what I gained. Then it says, and g of x is sine x minus 1. This here means the whole of sine x was shifted down 1 unit. It means that its maximum changes and its minimum changes. Its maximum originally was 1. We got to lower it by this 1. So that means its maximum is going to be 0. Its minimum was negative 1. We got to lower it by this 1. So its minimum is going to be negative 2. Okay, for the interval, x is an element of 0 to 270. So they're telling us only from 0 till 270 degrees. All right, there's the graphs. What I want you to do first when you see this question, highlight each of your graphs in a different color. So let me do that, okay? Okay, so I highlighted them. I highlighted my F in purple, and I highlighted it there as well, purple, so that I know its formula. And I highlighted my G in pink. There it is, G is in pink. The first question says, write down the period of F. Okay, now we know that F is a cos graph, and we know that the period of a cos graph is 360 degrees. I mentioned that at the beginning of my video. So 360 degrees, and there we go, we got our mark. Okay, this one here says write down the range of g of x. I just said this now, the original range of it, or the minimum and maximum, let's write it down over here for you. Okay, the original one would have been negative 1 and 1. I mentioned that at the beginning of the video. This here is getting dropped, or bringing the entire graph down by negative 1. So now it's going to be y is an element of negative 1 from here, minus 1 more, and this 1 minus 1. So this here is negative 2 and 0. So we can write down our answer now. That was our thinking. Y is an element of negative 2 up until 0. That's one way of thinking it. Another way of thinking through it, let's look at the graph of g of x, the purple one. Right? Let's look at, oh no, it's a bit difficult to look at. Never mind. I was going to say we can look at its minimum and maximum, but as you can see, it's stopping here at negative 1. But we know this graph is going to go further down. Alright, so forget that. You can't use that. The next question says number of solutions for where f of x is equal to g of x. When I say two graphs are equal to each other, I mean where they're intersecting with each other. Okay, and it says in the interval 0 degrees to 270. All it's telling you is we just want it for this amount to this amount. Don't go further than it on this side, and don't go further on it on this graph on the other side. So where are the graphs equal to each other? Can you see they're equal to each other over there and they're equal to each other over there? There's two solutions. So how many? 2. And that's it. You get your mark for that. All right. Next question. For which values of x in the interval, and this is what I did in this previous page, is like the stuff over here, right? For which values of x in the interval, so again between 0 and 270 degrees, is f of x times g of x greater than or equal to 0. Now we discussed this already. If I say this, I mean where is it positive times positive, or let's draw a line here. Where is it negative times negative? That's what I want to know. All right. So I'm going to quickly just sketch this graph over here. One time here for me and one time here. And then I'm going to show you what I'm doing afterwards. Okay, I went ahead and just made 2 simple sketches for myself so that I can highlight on it, okay? So we already said positive times positive gives us a positive. So I'm looking for where my f of x is a positive. So over here, I forgot to label it. This one here is f of x. This one here is g of x. F of x, g of x. So where's my f of x? A positive, meaning where is it greater than 0? It's greater than 0 over here, or greater than 0 being the x-axis, above the x-axis. And then the part where it says where's g of x a positive, again I mean where's my g of x graph above the x-axis. Can you see in this one here it doesn't go past the x-axis, so we're not going to highlight anything for that part. That means there isn't going to be a solution on this side. Let's move to the side. I'm asking where's my f of x a negative, meaning below the x-axis. F of x is below the x-axis, this part here. Let's just highlight that a bit better. There we go. That's where it's below the x-axis. Now I'm asking where's g of x below the x-axis, meaning negative. It's all of this part. Yeah, it's basically the whole graph given to us. We now want to see where it's intersecting with each other. So I'm going to draw my lines for my important points. Okay, let's show you what I meant by that. This one here, we know we're not doing any solutions, but I'm just showing you there's an important point. There's at the 180 is an important point. Cutting 2 graphs there, important point, and the 270. Let's do it here. 90 degrees, the 180, the 225, the 270. So let's write down our solution where both colors are happening at the same time. Can you see here from 0 to 90, only one part of the graph, or one graph is highlighted. From 90 all the way to 270. Can you see both graphs seem to be highlighted at the same time? Highlighted, 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 highlighted. Everywhere it's highlighted. So my solution is from 90 to 270. So I just write down 90 degrees, x, 270 degrees. I go back. It wanted it with equal to. So equal to, and that's my answer. And then next question, last question for this video. I'll make a separate one if anyone wants more explanations or more past papers. It says the graph H, so this is a new graph that we're talking about now, okay, is obtained by reflecting graph G. So we're taking graph G, we're reflecting it about the x-axis. Let's write down what we think that's going to be. H of x is going to be G of x that's reflected about the x-axis, meaning our y's become negative, right? Which is the same thing as, let's take our g of x, and we're changing all the signs of everything, right? So I want to write it down like this, and it's going to make more sense in a second. This here is, let me write here, negative g of x is the same thing as sine x minus 1. But I don't want the negative. What I did is I took this here, and we know g of x is what I just showed you over here, right? But I don't want this negative over here. I want g of x on its own. So I'm going to say g of x, or h of x, right, is the same thing as negative sine x, and negative divided by the negative there, plus 1. That's what it is. So that's the graph of h of x. Let's name it here, h of x. Right? It wants to know what's the coordinates of the minimum turning point of H. Now, because this is a sine graph, we know that it turns. Let's go back. Where did I do all of my? Here it is. Okay, a sine graph, we know it turns at 90 degrees and 270 degrees, isn't it? This one over here, we need to figure out what the graph would look like, or where is it going to be turning. So let's just sketch. It was negative sine x plus 1. That's, oh, sorry, very poorly drawn, but stay with me. This is what negative sine x would look like. Right, on top, that's the negative sine x. On top of that, we add in 1 to it. So this is what, oh, something like that, okay? This is what it's going to look like. Yeah, that's what it's going to look like. So where's its minimum? Can you see its minimum should be here? It was at 90 degrees, and it was supposed to be at negative 1, but instead it got, oh, my graph is a bit poorly drawn. Let me redraw this. Okay, this is not happening. Let's get this right. Right, so this is what it's supposed to look like, but everything is getting shifted up 1 unit. So this here should have been at negative 1. It's now going to go here at 0. This here should have been at 1. It's now going to go to 2, isn't it? And it's going to come down like that. That's what's going to happen. Very poorly drawn graph because my paper seems to be moving. But the minimum turning point is still here at 90 degrees because all of our turning points are at 90 degrees. I just showed it to you over here. 90 degrees to 70 degrees, right? So the minimum one means the lower one. It's now at 90 degrees, and at this here, this coordinate for y is 0. So let's write down our answer. 90 degrees and 0. And that's it. That's how you answer that question. All right, you don't have to show any of these calculations. You don't even have to show the graph. The graph is for us to understand, because I keep saying most of us are visual learners. So this is to understand it visually. And then you just put down your answer. Okay, I'll make a separate video if anyone wants on a different question. I'm done with answering this question.